How to find the composition of functions. Coming up, back into action. Hey guys, how to find the composition of two functions? What is the composition? If you are given two functions, let's say f and g, a new function could be made by taking g function as an input of f. So the output of g function could be made the input of f. So therefore a new function, it's called f kind of little circle g, so it's denoted by this symbol which stands for a composite function or a composition of two functions. Simply means that you plug in for x in f function entire g of x. So the idea is all about plugging in. It's similar basically when we evaluate the function at a given point. But instead of plugging in the number, we plug in entire function instead of x. Everywhere x appears. I think it's better to just take a look at some examples, and it might click when you see how it works. Let's say we are given 2x plus 1, this is your f function, and x squared, this is your g function. Now, find composition f, g. So f, this circle, little circle, g. So we could write the parentheses, and we need to attach this x. That means just we had the variable which is x actually. So by definition, this is basically official definition of the composition. Sometimes it defines in reverse order, but this is kind of common case, common definition that comes out a lot. So the first thing, you take g, and all you need to do at this stage, you replace your g with that equation that you are given. So your g is x squared. So just simply instead of g of x, you put x squared. So you would get, just keep this f as the outside, and instead of g of x, you would write x squared. This is your kind of first step. Now, the second step, you want to plug in this x squared into x. Everywhere x appears. So x appears basically just once in your f of x formula. So instead of x, you want to insert, you want to plug in x squared. Now, and you want to keep all these terms as is. You don't want to change anything besides this. So you would have 2. Instead of x, I'm going to write x squared. I'm just writing these parentheses in order to just emphasize it. So actually you don't have to write them. They doesn't make any sense at this point, but just to underscore this. Plus 1. And as I said, we could simply just ignore these parentheses. And your composite function is 2x squared plus 1. This is your f composition g. Now, let's take in the reverse order. So g composition f. So your f comes first. So whatever next to x you do first. So you keep g outside for now, and you take f of x first. Instead of f of x, I'm going to substitute, I'm going to plug in the equation of f of x, which is 2x plus 1. So, moving on, I'm keeping this g outside, and just instead of x, I'm replacing f of x with 2x plus 1. Now, we're going to do this g. So g is x squared. So instead of x, I'm going to substitute this entire expression. So you take this 2x plus 1 as is, entire, the whole, and you plug it in for x into your x squared, into your g of x. So I would have just 2x plus 1 squared. We're done. So technically we're done. So this is just binomial squared. If you like, you could expand it, FOIL it out, but technically it's done. That's answer. You could just simply FOIL it out, open up the parentheses, and either answer is fine at this point, so this is totally valid. You could leave your answer like this. It's just the matter of writing the trinomial or just a binomial squared. That basically totally fine. Now, as you could see, your f composition g is 2x squared plus 1. However, g composition f, so if we take this composition in the reverse order, you would get completely different result. And generally, to generalize and generally speaking, f composition g is not equal g composition f. So this is totally different from numbers. So for numbers we usually have as 2 times 3, which is 6. It's precisely the same result as 3 times 2. So, or for addition, 2 plus 3 equals 3 plus 2. For composition, it does not work. So the order when we take our function does matter. So it does matter which function comes first and which comes second. So if you flip, if you switch the order, generally speaking, the resulting functions would be completely different. So generally, so we would have this inequality between these two sides. Now, let's play with 3 functions. So besides this f and g, what we did in the last example, so you are given h of x, which is sine x. Now, let's begin with f composition h. So you want to apply h first. You keep this f outside, and instead of h of x, I'm going to write sine, since h of x is defined as a sine of x. Now, let's do f to sine x. So your f is 2x plus 1. That means instead of x, I'm going to plug in this sine x. So just sine x instead of x. So you will be left with 2 sine x plus 1. There is nothing to be simplified, so this is your composition of f and h. Now let's do it in the reverse order. So h, f. You apply f first, keep this h outside. Instead of f of x, I'm going to write the equation, which is 2x plus 1. So 2x plus 1. Now let's implement this h. So since h is sine x, so instead of x, I'm going to plug in 2x plus 1. So my new argument of the sine function becomes 2x plus 1. So you would simply get sine of not x but 2x plus 1. This is my new argument. And you cannot simplify it. This is just sine of something, sine of 2x plus 1. This is your final answer, final result. Now, if you come across something like f squared, typically that means that you need to find the composition of f and f itself. So typically f squared means the composition of function f and itself. So also if you are given something like f cubed, that means you need to find the composition of f 3 times. So f, composition f, and so on, blah blah blah, etc. So usually for f to the n, so do not confuse it with a power. It's not a power. It's not f raised to the second power. This is different. It's the composition. It's usually used to mean the composition. Now, for this f squared, all we need to do is just apply the function f twice. So by definition it's f of x, and instead of f of x I'm going to write 2x plus 1, since it's defined as a 2x plus 1, keeping this f outside. And now again I'm going to apply f to 2x plus 1. That means instead of x I'm going to rewrite 2x plus 1. So this expression goes into x into my 2x plus 1. So we are left with 2 instead of x, 2x plus 1, and this one to be precise is hanging around, so plus 1. And the last expression needs to be simplified for sure. Just open up the parentheses, FOIL it out. So 2 times 2x gives you 4x plus 2 times 1, 2, and this 1 hanging around. And you would be left with 4x plus 3. This is your a composite function, a composition of f and f, or f squared. Alright, the last one. So you are given g, composition f, composition h. Might look like intimidating, but don't worry. If you are given 3 functions and you need to find the composition, just all of them, just do it incrementally, in stages, step by step. So you want to apply one by one, starting with h. So I would use the square parenthesis for g, for that one. And you have f of h of x. So you start with h of x. it comes first. So you keep these two for now. So instead of h of x, since it's sine x, so I'm going to write sine of x. Now, we're going to use f to sine. Your f is 2x plus 1. So instead of x, I'm going to place sine x. All sine x instead of x. So you keep still this g outside. So instead of x, I'm writing sine. So 2 sine x plus 1. This one, do not lose it hanging around. And finally, we're going to use g. We're going to apply g to that function. So since your g is squaring x squared, so instead of x, I'm going to place this entire argument. So the whole this expression goes instead of x. You could think of this kind of empty box. So we're going to remove this x from this box, and instead of x, and instead of this x, so in this place, in this box, we're going to put in this entire expression. So you have this squared outside. So you would simply get 2 sine x plus 1 squared. So you could leave your answer like this. You don't have to open up the parentheses and fill it out. It's totally fine. So this is your answer for that GFH composition. Thanks for watching and train your brain. I know everyone hates maths, but if you like my video, please hit like, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss my new